Good morning everyone. So today we are going to see about stack ADT in data structure. So ADT is an abstract data type. So abstract data type is nothing but an object along with its operation is called as an abstract data type. List is an ADT since list is an object and you are having the operations of list as printing the list, inserting the element, finding the element, and deleting the element. Likewise, similarly, stack is also an object, and for the stack again you are having its operations like push and pop. Therefore, you can call this stack also as an stack ADT. Stack is similar to that of a list, but here the restriction is both the insertion and deletions will be performed at only at the end of the list, which will be pointed by the pointer called top. So we'll see an model of the stack. So the fundamental operations on the stack are push and pop. Push is used to insert a new element and pop is used to delete the most recently inserted element into the stack. So top is a pointer that will point to the recently inserted element. Since both the insertion and deletions are performed at the end of the list, stacks are also called as LIFO order. That is, it is following last in first out. The element that have been inserted last will be the first one that will be deleted first. So the last inserted element will be deleted first. So this is a stack model. So you can see the model of the stack. You are having an input operation as push since you are going to insert a new element, and pop is an output operation, and top will also be pointing to that most recently inserted element that can be deleted. So this is what the stack model, and in the figure, the second figure, they have given the way how the elements will be inserted into the stack. The first element that have been inserted into this stack is 6. After 6 you have inserted 3, 1, 4, 2. If you want to insert a new element 5 means the 5 will be inserted after that element 2 and top will be pointing to 5. So in this diagram, if you are going to delete some elements, you can delete only the element 2, and you can't delete the element 3, 6 or 1 instead, because since it is a stack, the most recently inserted alone can be deleted in this stack model. So this is the difference between list and stack. In list you can delete the element from wherever you want, so that is not possible in this stack. So stack can be implemented in two ways. One is linked list and also in the array implementation. In the linked list, you will be inserting a new element at the front of the list and you will be deleting at the front of the list. As we have seen, both the push and pop will be performed only at the end of the list, that is at the one end of the list. So array implementation, if you want to avoid links, you will be going for array implementation of stack, where you will increment the top of stack pointer if you are going to insert a new element, and you will be inserting at that top position, and if you want to delete it, you will be deleting the element that is at the top of the stack, that is pointed by the top pointer. So this is what the implementation of stack. So here there are 4 applications of stack: balancing symbols, postfix expression, infix to postfix conversion, and function calls. So we'll see one by one everything. So balancing symbols. So using stack you can check whether all the symbols are balanced, whether you have included all the symbols in the correct order. For example, brackets, parentheses, whatever you have included, both all those things should have opening and closing thing. So just to check that, you will be following some 6 steps in that algorithm of this balancing symbol. First you have to make the stack empty. Then second step is you have to read the characters until the end of the file. If the character you have read is an opening symbol, then you have to push it into the stack. That is the third step. And in the fourth step, if it is a closing symbol and the stack is empty, then you have to report an error, because surely the closing symbol will not be having an opening symbol since the stack is empty. So if it is not the case, it is having a matching parenthesis or some other symbol is there, means you have to pop the stack. If the symbol popped is not the corresponding opening symbol, then report an error. At the end of the file, if the stack is not empty, report an error. We will go through all these steps through an example, then it will be easy for you to understand. So initially the stack will be empty, and assume in the string you are having this brackets like a square bracket, parenthesis, normal brackets. After that you are having closing brackets in that order. So now we are going to check whether the symbols are balanced. By seeing that, we can check and say it is an the symbols are balanced. But how the system will check means, using the stack it will check. First it will check whether the opening symbol is an in the first step it will check the string you are going to read is an opening symbol. Since you are having an opening square bracket, it will be pushed into the stack. If you are getting an closing symbol at that point, means it will report an error. And in the second step, the next string, that is opening parenthesis, will be seen, that more it will be inserted there. In the third step, again one more bracket is there, that will be inserted. And in the fourth step, you are getting a closing bracket. Whenever it sees that closing bracket, it will fetch the top pointer symbol also. And the fifth step, it will find that fifth one is also a closing parenthesis, so it will fetch the closing bracket, and it will pop that particular symbol that is pointed by the top pointer. And similarly you will be doing at the fifth step also. So at the end of this step, you will find, at the sixth step you will find that the stack will be empty. So if this is the case, you can assume that the symbols are balanced, they are in the correct order. So the next one is you will see about the postfix expression. Postfix is nothing but the operands will come first and the operators will come at the last. So this postfix expression is also called as an reverse Polish notation. Whenever a number is encountered, it will push it into the stack, and whenever an operator is encountered, the operator is applied to the top two numbers, and they will be popped from the stack, and they will be calculating the value, and finally they will be pushing the result into the stack. We will see an example. So assume you are having the 6, 5, 2, 3 plus 8 into plus 3 plus star. This is a postfix expression. So how you can identify this expression as a postfix means, operands are coming first and the operators are coming next to the operands. So if it is a number, it will be pushed into the stack. So first expression, in this expression the first one is an operand, therefore it will be pushed into the stack. Next is also an operand, so that will also be pushed into the stack. Next 2 is also an operand, and 3 is also an operand, so it will push all the first 4 numbers into the stack. The next one is an operator plus, therefore whenever it will encounter an operator, it will pop the last 2 elements that have been recently inserted, that is 3 and 2 will be popped from the stack, and you will be calculating using that operator plus, you will calculate the value. Therefore 2 plus 3 you will get 5. After getting 5, that 5 should be inserted into the stack. So that is what in the second diagram you are getting the result 5 and the already existing numbers 5 and 6. So this is the second diagram. After that you are getting a value as 8. So since it is an operand, it will be pushed into the stack. Next is star. Star means it is an operator, therefore you have to pop the last 2 elements, that is 8 and 5 from the stack. So if you calculate 5 into 8, you will get the result as 40. Therefore in the next step 40 should be inserted, that is pushed inside the stack. Therefore you will get 45 and 6 in the next diagram. So after that star, you are having the value as plus. So what happens? So that 40 and 5 will be popped from the stack, and you will calculate the value. The result is 45, that will be inserted into the stack. And after that plus, you are having the value as 3. Since 3 is an operand, it will be pushed into the stack. Next you are having an operator plus. Since it is an operator, the last 2 elements 3 and 45 will be popped from the stack, and you will you will do that plus symbol, that is plus operator. You will be adding the two values 45 and 3, and you will get the result as 48. That 48 will be pushed inside the stack. So after that you are having only two operands inside the stacks, 48 and 6, and the last operator in this expression is star. Therefore you will fetch that 48 and 6 and you will perform multiplication. The result will be 288. So if you calculate postfix expression using the stack, you will get the output as 288. That will be pushed into the stack. So this is the way how it will evaluate postfix expressions. So next we will see how to convert an infix expression into a postfix expression using a stack. So infix means the operator should come in between the two operands, and postfix, as we have already seen, it should be converted in such a way that the operator should come at the last. So first we will see an example. So you have going to convert this infix expression a plus b star c plus d star e plus f into g into the postfix expression. So whenever you are reading this expression, if an operand is coming there, you have to place it immediately into the output. If you are getting a close parenthesis, you have to pop the symbol from the stack. Until you are getting an opening parenthesis, you have to pop it. So whenever you are getting an operator, you have to pop all the symbols and you have to calculate it. So we will see the example, then it will be easy for you to understand. So you are having an infix expression a plus b star c plus d star e plus f star g. So first in the stack, you are in this expression, you are having the value as a. A is an operand, therefore it will be printed in the output as a. The next one is plus. Since plus is an operator, it will be pushed into the stack. The next one is b. Since it is an operand, you will be writing it in the output. The next one is star. Star should be inserted into the stack, but already there you are having the operator as plus. So you have to check whether plus is having lower precedence compared to this star. Since plus is having lower precedence, you can push this star into the stack. The operator you are going to insert inside the stack should be of higher precedence. So that is the only rule here. So after that star, you are having the operand c, therefore you will be printing it in the output. Next to c, you are having the operator as plus. So plus, and but already in the stack you are having most recently inserted operator is star. So you can't insert plus inside the stack since plus is having lower precedence than star. Star is having higher precedence, therefore star should be, you have to pop that star, and next you will check plus with plus. There again it is equal. It should not be equal. It should be less than the operator. Then only you can push it into the stack. Therefore you will pop that plus also in the output. And after popping the star and plus from the stack, now you will insert that plus inside. Now after C you are having one operator plus, no, that will be inserted into the stack after popping star and plus. And after that you are getting the opening bracket D. Since the opening brackets will be having higher precedence always, it will be inserted inside. And the next one is D. So since D is an operator, since D is an operand, it will be printed in the output. Next is star. Inside that bracket you are not having any other operator, so you can insert star. Next one is E. So you can, since it is an operand, you will be printing E. Next one is plus. Since plus is having lower precedence, you have to pop out star and then only you can insert plus. So that is what given in the next diagram. And after that you are having the operand as f, that will be inserted. After that you are getting an closing brackets. If you are getting a closing bracket, all the operators that are inside that opening and closing bracket should be popped out. The only operator that is inside that bracket is plus. So therefore after f, plus will be popped out. After that you are having an operator as star. Since star is having higher precedence than plus, you can insert star you can push star into the stack. The next one is G. G is an operand, so you have to output it in the output, you have to print it in the output. After that the expression is over, so you have to empty the stack. So in the stack you are having star and plus. Star will be popped out first and then plus will be popped out. So this is the way how you will get an postfix expression from the infix expression. So this is the way how you will get an postfix expression from infix expressions. So the last application of this stack is function calls. When there are when a function is called, its address will be saved in the register, so that whenever you are calling that function, that particular function will be called from that register. So the if you are having new functions, you are calling one function within another function, all the addresses of those new functions will also be saved in the register, so that whenever it is called you can access it clearly. So when the function wants to return, it will return to the correct registers. So here you can see you are having void bar and void foo. Inside that foo you are calling the another function bar, and in the main function you are calling only the foo function. So what happens in the stack, initially main is the first function that will be called, so main will be called first. So inside the main function you are calling the foo function, therefore in the stack after main foo will be called, and in the foo function you are calling the bar function, therefore bar function will be again called. So this is the order in which the functions are called one by one. After bar finishes its bar function finishes its operation, it will return. So where it will return? It will return to the foo function. Similarly, foo will perform its operation, and it will, after finishing its execution, it will return to the main function, and main function after finishing its calculation, it will close the program. So that is what at the end of the stack it is empty. So this is the order in which the functions are called and they are returned. Everything will be stored in the register, so that whenever a function is returning, it will return correctly to that calling function. So these are all the introduction about the stack ADT and its applications. Thank you.